All right, today we're going to pull back the curtain on the brilliant idea that makes everything from ChatGPT to these incredible AI image generators actually work. It's called the attention mechanism, and it's really the secret sauce for how machines finally learn to understand context. So how on earth does it work? I want you to just look at the word mole in these three sentences. You've got an animal, a unit of measurement for all you chemistry fans, and a skin growth. Now, for us, figuring out the meaning is a piece of cake, right? It's obvious because of the other words. But for a computer, this is a massive, massive challenge. How does it possibly know the difference? Well, here's the problem. At first, it can't. When an AI initially sees these sentences, its internal representation, its sort of digital idea or vector for the word mole is exactly the same in all three cases. It's just a generic context-free definition. You can think of it like each word is an island, and there are no bridges connecting them to the mainland of context. So how do we build those bridges? The huge breakthrough came in 2017 from this landmark paper called, perfectly enough, Attention is All You Need. It introduced the attention mechanism, which is basically a way to let the words in a sentence literally talk to each other, to pass notes back and forth, to figure out what they all mean together. Okay, so this process happens on a truly mind-boggling scale. But to really get it, we're going to zoom way, way in and look at just one tiny piece of the whole operation, what's called a single head of attention. Let's watch this little conversation between words happen one step at a time. Let's use this simple phrase as our guinea pig. The word we really care about here is creature. On its own, that's super generic, right? It could be anything. But we know it's a fluffy blue creature. The goal here is to get the meaning of fluffy and blue to sort of rub off on and update the meaning of creature. You can think of this whole word conversation as a simple three-step dance. First, a word asks a question about what's around it. That's the query. Second, all the other words offer up potential answers. Those are their keys. And finally, the words with the best answers get to share their meaning, and that's their value. Query, key, value. That's it. So first up is the query. Our word creature sends out a signal, which is really just a bunch of numbers called a query vector, but you can think of it as creatures shouting out, hey, any adjectives over there that are describing me? And you know what? Every single word in the sentence is doing this at the same time, asking its own unique question. Next up, the key. So creature asked its question, and now every other word provides an answer with its own key vector. It's like the words fluffy and blue both shoot their hands up and say, yep, I'm an adjective right here. I might be what you're looking for. Their keys are basically a perfect match for the question creature just asked. Okay, so how does the model know which answer is the best? Well, it calculates a relevance score between every single question and every single answer. This creates a grid, like the one you see here, called an attention pattern. And look at those high scores. That's the model realizing there's a super strong connection when the question from creature lines up with the answers from fluffy and blue. It's like a bright, flashing light telling the model exactly where it needs to pay attention. And that brings us to the final and most important step, value. Because fluffy and blue got those top relevance scores, they get to share their meaning. See, every word also has what's called a value vector. That's the actual stuff, the semantic information it carries. In this case, they get to pass the very essence of fluffiness and blueness over to the word creature. And here's the beautiful result of that whole dance. The model takes those value vectors from fluffy and blue, uses the high attention scores to decide how much of them to use, and then adds them to the original vector for creature. So that generic, boring creature vector is now transformed. It's become a new, much more specific vector that really represents a fluffy blue creature. It has literally absorbed its context. Okay, so that was just one word in one tiny head of attention. It's a neat little trick for sure, but the real magic, the reason this changed everything, is the absolutely insane scale this system operates on. So let's zoom out and see how this one simple idea builds the powerful AI we have today. A model like GPT-3 doesn't just have one of these little attention heads. No, it runs 96 of them, all at the same time, in parallel, inside just a single processing block. That means for every word, there are 96 different conversations happening simultaneously. So why on earth would you need so many? Well, because each head can learn to be a specialist. One head might get really good at linking adjectives to nouns, just like the one we saw, but another head might focus on figuring out what a pronoun like it or he is referring to. A third might learn to connect words that are conceptually related, even if they're super far apart in a long document, like spotting that the word wizard and the name Harry probably have something to do with each other. But wait, it gets even bigger. The model doesn't just have one block of 96 specialists. It stacks these blocks on top of each other. A model like GPT-3 has 96 of these layers. So, a word's vector gets updated by 96 heads. Then that new, smarter vector gets passed up to the next layer to be updated by another 96 heads, and on 96 times. When you do all the math, the number of parameters in the model that are dedicated just to this attention process is absolutely staggering. For GPT-3, it's nearly 58 billion. That's the kind of massive computational engine it takes to build such a rich, flexible, and contextual understanding of language. So the shift in thinking here is just profound. Before attention, you had words that were like those isolated islands of meaning we talked about. But with attention, they become part of this deeply interconnected web, where every word can influence and be influenced by every other word. You get a holistic understanding of the whole thing, not just the parts. So let's boil this all down. What are the big things to remember? First, attention is what lets AI go beyond a dictionary definition and truly get context. Second, the way it's built is perfect for modern computer chips, which allows it to scale up to these enormous sizes, and that scale is what unlocked all this incredible performance. And finally, just remember that this is the core engine driving the amazing language skills of pretty much every major AI you use today. And that kind of leaves us with a big, provocative question. For decades, context was the missing piece of the puzzle. Now that machines are starting to get a real handle on it, what's the next great barrier to true understanding? What comes after attention?